Good morning, Algebra 1. We're continuing our unit on pre-geometry, and today we're going to focus on midpoints and distances. You will need your calculator, so go ahead and get that out now. We're going to start off with a real-life example. So imagine we have a soccer field, and we'll place a grid on the field. It says a player kicks a soccer ball from a position that's 10 yards from the sideline and 5 yards from the goal line. So here's that soccer player kicking the ball. Here's the 10 and 5. The goal line is at the bottom, so think about that as being your x-axis. And think about the sideline as being your y-axis. So we have the point 10, 5. And then the ball lands at a position 45 yards from the same goal line and 40 yards from the same sideline. So now that's the point 40, 45. And so our first question is, how far was the ball kicked? So we want to find this distance. And so how to find a distance between 2 points? Let's imagine that we take this grid and we create a right triangle. And so from yesterday we learned the Pythagorean theorem, and we can just use the Pythagorean theorem to find the distance that our ball was kicked. So to use the Pythagorean theorem, we need our distances on the legs. So for example, if we travel from 10, 5 over here to this corner, and that's at 40, 10 to 40, that's going to be 30. And then if we travel up from 5 to 45, that's going to be 40. So these legs, we're going to call those the change in x and the change in y. And you'll remember we did that when we talked about slope, rise over run. So our rise was 40 and our run was 30. And we'll use that same bit of information to find our distance. Because now we have this right triangle with our 30 and 40 as the legs, and we can use Pythagorean theorem to find the distance that our ball was kicked. So we're going to take the square root of 30 squared plus 40 squared, and that'll tell us the length c. Now you might need your calculator. The 30 squared is 900, 40 squared is 1600. We can add those together and get 2500. And the square root of 2500 is 50. And so our ball traveled 50 yards. So the basic idea of finding a distance, a lot of people use d for distance, but that's up to you. We're basically going to take the square root of our change in x squared plus our change in y squared. And now for the midpoint, for example, if another player intercepted the ball halfway between the 2 points, where would this point of interception be located? So we want the midpoint. We want halfway in between our point 40, 45 and our point 10, 5. If we eyeball it, it must be somewhere right about here. But how can we tell for sure? Since it's in the middle, we could find the median or just the average of the two coordinates. So what we can do to find the average, let's do the average of the x first, 40 and 10. That would be 40 plus 10, and we'll divide it by 2. And then the average of the y values would be 45 plus 5 divided by 2. Let's calculate those. 40 plus 10 is 50 divided by 2. 45 plus 5 is also 50 divided by 2. So we have 25, 25. We look at our diagram, yeah, that looks about 25, 25. And that's where the midpoint will be. And that's where the ball was intercepted. So again, to find the midpoint, you want to find the average of your x values, and you want to find the average of your y values. And just add them and divide by 2. Let's just try some generic examples. So for our distance, we need to find our change in x. Change in x squared plus change in y squared. Well, how can we find the change in x? Well, from 1 to -3, how far away are those numbers from each other? They're 4 away from each other. You might need to subtract in your head 1 minus -3, and that would give you 4. And then how far away are the y values from each other? Well, from 5 to 1, that's also 4. Again, you might have to subtract. When you subtract them, you'll need to get a positive answer because these are distances. Remember that. So everything should be positive. So we have 4 squared plus 4 squared, and that's 16 plus 16 is 32. And now I'll use my calculator to tell you the square root of 32 is about 5.7. And then for our midpoint, we're going to find the average again. So if I take -3 plus 1 divided by 2, that'll be the average of the x values. And then 1 plus 5 divided by 2 will be the average of the y values. -3 plus 1 is -2 divided by 2 is -1. 1 plus 5 is 6 divided by 2 is 3. Just double check on our diagram. -1, 3, that looks about halfway between. Let's try one more. So for the distance, I need my change in x and my change in y. From 5 to -1, I have 6 units. And again, if you need to subtract, that's okay. From -2 to 1 would be up 3 units. -2 minus 1, I would get -3, but again, distance is going to be positive, so we'll just use the positive value. So my change in x squared plus change in y squared, 6 squared plus 3 squared. Let's see, that's 36 plus 9, that's 45. And the square root of 45 is about 6.7. Again, with the midpoint, we're going to find the average. So let's add the x values, -1 plus 5, and divide by 2. 1 plus -2 divided by 2. -1 plus 5 is 4 divided by 2, so we get 2 for the x value. 1 plus -2 is -1 divided by 2, so we get a fraction for the y value. So 2 comma -half. And so if we go over 2, remember this scale is going by 2, so if we go over 2 and down a half, that looks about right. One more quick example on a number line, just in case. Use the number line to find the following. The midpoint of the segment WY. So if we go from W to Y and we wanted to find the midpoint, again, we can do the average. So -5 plus 7 divided by 2. And we would get 1. And so that would be located right here, the coordinate 1. And then part B, all they say is XZ. What that means is they want us to find the distance between the points X and Z. So the distance between -1 and 4, how far away are those from each other? We would get the answer of 5. Again, for the distance, you could find the change and subtract the two numbers. Remember, distance will always be positive. If you went the other way, you would get a positive 5. But either way, our answer will be 5. Have a good day.